Imperva protects applications wherever they live and at the pace of development. From securing applications at runtime to protecting APIs in any cloud environment, only Imperva offers a unified solution across edge, application, and data to help you achieve more and save money. Start a free trial today and quickly protect your web applications at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. We just talked with Mike Benjamin about GraphQL, template injection, and creating more secure defaults in apps that have more visibility. I am your host, Mike Shima, and I'm here with John Kinsella, and it's just about time for the news. First, do you have a specific guest or topic that you want us to cover on one of the shows? Submit your suggestions by visiting securityweekly.com/guests and completing the form. We review suggestions monthly, and we'll reach out to you once reviewed. This week, join us June 29th for a webcast with Tyler Robinson and Bo Bullock to learn how to pivot into the world of crypto security. Visit securityweekly.com/webcast to register with only your name and email. Plus, don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. John, we are now pivoting into quite a long list of news for the week. I've got some broad, thinky piece reports. I think you've got a survey, but we also have a couple of bugs, I think, to talk about first. So one quick one I wanted to start us off with was OpenSSL, and this article is just talking about patching a patch, and a little bit hand-waving over what the specific bug here is, and more pull out that aspect of the practice of saying, here's a bug that's reported through a fuzzer, which we'll get to shortly, or a bug bounty program, or just a random person on the internet discloses a bug in your software, taking that bug and then looking for variants, looking for where else within this code base might this exist. And this is a good practice. I don't know how common the practice is, unfortunately, but that's one of the reasons that they're patching the patch here from OpenSSL. And as a reference, the other reason I brought this up is that we talked last week with the Synlapse flaw, where we saw Azure patch the issue. Orca Security said, we found another bypass. They patched it. We found yet another bypass. So clearly there's a lot of patching that has to be done properly within these vulnerabilities.
Yeah, definitely. They and this was an interesting one. Let's see, there's a sentence in here I'll try to track down as I talk. But I mean, it's we can make the joke of it's time to come back and have the latest OpenSSL vuln, but it's complex code, so I get it. But yeah, and how do you? So there's a section in here talking about the author of this piece of the blog saying, "Hey, I've no doubt that they're testing to make sure everything is right coming out of this square root function." So what's going on here? Well, I don't think we talked through it yet. Part of what as OpenSSL is going through and doing a validation of the certificate, it needs large numbers, and then it's factoring them. So one of the ways it does that is to look for square roots. And on that, this is where the author of the blog, Naked Security Blog, was talking about, I have no doubt that their use cases have all sorts of numbers that they put in and then look at the numbers coming out to make sure that they're valid. But the question is, are they doing the negative test? And that was probably maybe not. And it's open source. I guess in theory we could go see. But yeah, that's what you end up here with is you think you have a fix. And that's probably similar. I don't know if I could say it for sure, but I'm guessing at least to a degree that's, like you said, Mike, similar to what we saw over with the Azure issue and lots of other things. It's when you are under the pressure and someone says, we found a security bug, it's like visible to our users, we have to get this fixed as soon as possible. Everyone goes, or most people go, oh my God, and they start typing quickly. I think I found the problem, I got it fixed, and then they move on. They don't sort of take the step back, take the deep breath and go, okay, is that really fixed? Or how else could I look at this, right? It's sort of, I guess, in a way, frequently when I talk about the security thing, right, or AppSec in general, it's a developer's been given a problem. He looks at it from his point of view. He sees the answer, but he, she, who, you get the idea. That person never takes a step back and goes, okay, I've created this really cool functionality. Could it be used for evil, or could it be used for bad, or could it give access to something else? And that same sort of logic, I guess, is probably similar to what causes these bugs to not get properly fixed the first time. The person fixing them looks at them from their particular point of view. They go, oh, I think I've got that. and they fix it, and they say, good to go. I got the bug closed in 15 minutes, able to go on to the next thing. My numbers look good. But in reality, when we look a little bit closer, we realize, no, not quite so much. So testing is super important. What more can I say on that? It's sort of, it's test, figure out, where is the sensitive portion of that code, and do as much as you can with it. On the off air after our last segment, I was talking to Mike about object validation. We're talking about from GraphQL, like how do you actually do that authentication of a request at the object level? And it's much more difficult to do than it sounds like. And we were teasing, maybe we'll bring it back for a future episode and dig into that particular thing. But how do you actually do that authentication and authorization? Well, I guess more authorization of every request at the object level. And then how do you do the testing around that to make sure that the authorization is working and is set up the way you want? And even at the organizational level, the person who knows enough about your application and your users and the data that's able to make the calls about which objects should have which type of authorization levels for which users, that person probably doesn't want to be doing that. So it's a very sort of tricky thing how you do these things right. A, just set up the structure for them, but then also B, do the testing to figure out what is and isn't legitimate use or a legitimate response. So a bit of a tricky thing.
Absolutely a tricky thing, because I think what you're getting to is that context is important for those authorization decisions, and just looking at something to say, should person X, Y, or Z, should this user type have access to this data field? Well, maybe, probably. But what happens, and I think Mike used the example of, well, we've blocked access to enumerate all of the images, but what if you can enumerate users and part of the user is a link to the images within their profile, for example? Suddenly you actually now get access to the exact same data, where one side of it, your GraphQL authorization said, nope, no access. The other side said, oh, sure, access to the profile, without having that context in mind. And maybe that's we've got a couple of other flaws to go through, but maybe this is a good way to pause for a second and bring in an article that you highlighted, in the sense of, we're talking about OpenSSL issues. We're talking about, in the past, we talked about Synlabs, a whole bunch of other flaws, all these CVEs. I was a bit down on CVEs in the intro in the last segment, but maybe only 3% of these bugs at all are attackable, meaning risk. Tell us a little bit more about this.
Yeah. So full disclosure, we've got a few stories we're talking about today that are being pushed by various different vendors, we'll say.
Yes.
And I'll leave the names alone for now. People can go and look. One will probably say the name. And it's not necessarily a bad thing. Let's see, the date on this came out on, I'm just looking to see if these came out from RSA. And no, they're recent, so they're after RSA. They're the type of articles which come out for RSA. But in this particular one, it starts off with the vendor, but they get a few others out there in the industry to sort of chime in. So it's a fairly even piece. But the general idea is being, just because there's a vulnerability in an open source package, that even if obviously if you're using it, doesn't mean your software is vulnerable. The example which is coming to mind for me, I can't even remember where it is in my code. Some part of my code is importing, I think it's etcd or something else from a container / Kubernetes stack. It's in Go, right? So dependency trees. So once you import one thing, you've got like half the planet. And somewhere down in there's like a containerd vulnerability that GitHub likes to tell us about. But I'm not doing anything even close to that within like 100 miles, right? So it's like completely false flag. And luckily that one's clear enough that I can look at it and go, no, that's not a problem. For a lot of these, it's a lot closer to what the code you're working on. So it can be a little more tricky. But either way, that the point is, for just because a vulnerability exists, and it's, we were talking again last half about prioritization. How do you prioritize what you're doing in these things? What do you need to fix first? And this is a great example of it. Is if there's, pick a nice round number, 100 vulnerabilities, open source vulnerabilities in your software, God help you. But if there are, and only 3% of them are legitimate, how do you actually figure out in that list what it is, right? It's not just, are you using that software, but are you using it under right conditions? One of the fun things about that last piece we were just talking about with OpenSSL the tricky part about that one in particular is the only people who are vulnerable to that particular vulnerability is those that are properly validating TLS certificates, which a vast majority of people don't do. So if you just happen to be run-of-the-mill Joe, whoever, who quickly coded up some OpenSSL stuff or TLS stuff and you're using it, and you're not validating the certificates, that vulnerability never would have bothered you. But if you're actually someone who's doing security and try to do the right damn thing, that's when it actually sort of bites you in the face. So a lot of these things are like that. There's a very certain set of circumstances which are needed to leverage these vulnerabilities. I think I've talked about in the past, like if I'm doing a demo of a vulnerability for like a vendor or something, actually getting all the pieces set up and right so I can reproduce it on stage live and not have it sort of backfire in my face, that's a little more difficult than people might think it is. So that's where this particular story is talking about. Like I said, they've got a few other ones talking through it. If you don't mind, Mike, I'm going to pivot over to the exact opposite side of that coin and talk about the State of Open Source Security report, which came out. And this one's from you, so I'm going to let you run with it first, and we'll sort of compare and contrast between the two. How about that?
That's a great idea, because to me, part of my one of my reactions to something like Attackable is, I kind of agree. And one of my thinking is not all bugs need to be fixed right now, which is the time dimension of the prioritization. I think they should be eventually, and maybe we should talk about what that eventually should be. Is it order of days or months or so on? I think the State of Open Source Security could possibly help us think through that, or at least gives us some things to think about. Just speaking of dependencies, go ahead.
Real quick, you just reminded me before we dig down into this. I do want to hear to compare and contrast. Excuse me, but we had an article sometime in the last few months talking about, I don't know, another percentage. 70% of developers or programmers release code into production that they know has a vulnerability in it. So we just said that, maybe not vulnerable. Right. All these sort of stats are sort of, you got to sort of put them together and sort of throw a dart at the board and figure out which one you want. But please go ahead.
Yes, and I think since we're throwing darts, also you mentioned, God help you if you have about 100 dependencies in your app. Well, on average, what this State of Security Open Source Security report says, if you're running a JavaScript application, on average, you're going to have probably 174 dependencies. On the other hand, if you have Python, it probably only maybe 25 dependencies. Go, on average, might have 56. But overall, I think the number was 80 dependencies just within your source composition graph of this whatever open source project you're pulling in. So already, that's quite a bit. I think another thing that speaks to this time dimension that we're talking about now is sadly something that doesn't look good in terms of a difference from 2018 to 2021, is that in 2018, the report says the time it took to fix vulnerabilities in open source projects looked like around 49 days. But now in 2021, that's doubled up to 110 days, which again seems like, are we necessarily riskier? That doesn't necessarily seem bad in the perspective of all these open source, they're not getting compromised, they're not getting attacked. Maybe it's okay for it to take more time, but I would still look at that and say, is that time because of a explicit prioritization choice, which I would acknowledge, or is that time because it just takes, there's less attention, there's less hands on keyboards to be able to do that fixing or something like that. So that's one of those areas that starts to maybe worry me or think about this a little bit more. I have a couple more aspects as well, but I don't want to steal the show here. So let me throw it back over to you and see if that's resonating with you, or if I'm completely off base here.
You're never completely off. Excuse me. Yeah, I agree with what you're saying. I think probably the biggest thing which came out of this particular story for me, a report, was where to go. To be secure, you need an open source security policy, right? And I think this comes down to we ran out of time at the end with Mike again in the last half. But if you're designing an API, we'll start there and we'll come into this. If you're designing an API from the beginnings in 2022, you really do need to think about who's going to be using this thing, what's its scale, how is it going to be used, how do I need to secure it, what type of data am I accessing? It's a fairly, it's a pretty complex thing. And I think this is sort of similar. If you're using open source, I don't expect anyone to do this when they first start using open source. But as your application starts to grow, at some point, preferably sooner rather than later, start thinking about, okay, well, if, when that Dependapot little icon pops up, or whatever tool you're using, you get a ping about some sort of new vulnerability, how do you handle that? And, how often do you do, maybe like once a week you go through and review? Do you say you're going to have these things patched within less than 180 days? All these sort of things, just having that conversation ahead of time allows, when something happens, allows you, it becomes operational, right, and operationalized. And how do you respond to it? I think where you're going is generally right. I think the interesting thing to me is this particular story, and again, it's one of these companies is selling a tool to find your vulnerabilities. The other one is selling you a tool to block the vulnerabilities from being executed. So there's sort of two sides of the coin is how we're looking at this. But I think the reality falls somewhere in between. And I think sort of the response of like, how do you, knowing what's out there, I think one of these, so one of the surveys in here, what tools do you use when you're developing open source software? And almost 20% of people didn't know. So I think that's, and the other answer is just to talk them through SCA, SAST, ISC, web app scanners, pretty much anyone can think of in here, ISC scanners, fuzz testing, threat modeling, things we talk about in the show every week, but 20% of those folks didn't know what they're using. And I think that's the part that really needs to be sort of, at least have some sort of idea or sense or discussion about, should we go looking for a tool, or how do we know what's out there? I think that's the part for me.
Yeah, and in the last segment, Mike he was talking about maturity, and that's, I think, speaking very much what you're highlighting here too. And to pull out another metric from this statistic from this report, they said roughly a third of organizations didn't even know who's responsible for the open source software security. So that does speak to, I think, what you're saying. At least set up a program. At least, if you say we should fix things, have a policy for, well, who should be fixing them and when, just a rough SLA. And again, it could be the idea of, we're just talking about an order of magnitude of weeks or months, but you're at least talking and tracking it. I did love to see, I'm changing slightly here, I did love that fuzz testing was on there, only 13% adoption, so hopefully that gets bigger. Threat modeling was on there too. I want to take a brief detour on that, because we talked about threat modeling in the first segment, and barely 10% of developers were talking about, or organizations were talking about, threat modeling tools as part of their solution here. And to me, that's not necessarily a bad thing to see that number so low, because I think in my mind, threat modeling is sort of something that is done earlier in the design phase. It's not a continuous effort. I don't think it's useful necessarily as a continuous effort. And it's not something that lends itself as well to automation. It's a great way to start out in those conversations like you brought up, John. How is this authorization on this object, this authorization model? What could go wrong here? Have we thought this through? Or if you're thinking about, fixing this particular security patch, are we just doing a positive test? Or are we thinking about all the abuse cases around it? But otherwise, I do like seeing that threat modeling is pretty low here on use, and the others like SCA or even fuzzing is up there a little bit higher.
Yep. I don't know. I'd like to see. I would personally like to see threat modeling a little bit higher. I think we're hearing about it more than we used to. At least I'm hearing developers and dev teams talk more about threat modeling over the last year than I did the previous 2 or 3. So I think it's definitely getting a little more attention. I don't know. I think it is something ongoing, right? You need to think about, at least from my point of view, you need to think about when you're first designing something. But if you add new functionality, then that can almost be worse, right? How does that new functionality interact with the old one? Are we exposing new things that weren't there before? So I think it's still worth a little bit of a discussion. And the thing is, that's something you can do without, let's see, can I say this? I'm just looking through everything else in this list on this particular survey question costs money, except for other and don't know. Right? So threat modeling you can do for free. and that's it's grab a tasty beverage on a Friday afternoon and go, hey, what do we think about how our application is going, or buy the team pizza and just sort of talk about it. All the other ones, there might be open source versions of these things out there, but they're going to take a hell of a lot more time. So yeah, I don't know. It's interesting to discuss, and I think we've discussed it. So we can probably move on.
Well, let's try to move on. Since we're looking at big, hefty reports, we have one from Cloud Security Alliance, which thank you for not having this behind a registration wall, which isn't surprising since it's an industry org. And it's interesting because they've updated their list. I think the last one that came out was 2019, and this is a list of top 11 threats. Probably nothing that's going to be too surprising or worrisome here. Or, well, I shouldn't say worrisome, but too surprising. I should stop there. IAM is pretty much at the top level of your threats. And speaking of the last segment, insecure interfaces and APIs was number 2 behind it. But one of the things I liked about this particular report was also the format of it, in the sense that lays out 11 threats, and for each one describes a business impact, some key takeaways about it, some anecdotes and examples, which are helpful for putting context and telling the story of this is why we should worry about IAM. This is why we should worry about misconfigurations and having better change control, because this other company X, company Y ran into this problem and made it into the news. And it also does throw in, speaking of threat models, it actually has some mapping to Stride, which I could give or take Stride itself, but I thought it was pretty interesting that they did include that, as well as just to say, here now for this particular threats are some kind of governance-oriented, but some governance-related controls that you could take action on and help improve your cloud. So it is a really nice report in terms of raising awareness, helping with prioritization. So I'm going to use that as our keyword of the segment, perhaps, and then point to some controls or some ways to actually try to address some of these issues. So I know you've done a lot of work, particularly in the cloud. So I'm not sure how this ordering of these top 11 resonates with you, or there's something else in particular that stands out.
Good question. I haven't looked at this in a month or two. I know the guys who wrote this. I've actually had them on. Josh from CSA come on to the Seattle chapter of CSA to do a talk through these, so I'm familiar with them. And what I like about it is that it's simple and small, and maybe we can get them on an ASW. But I like that it's approachable, like you were starting to say there. It's not. If you look at a lot of the CSA research, a lot of those docs quickly get into 30, 50, 80 pages. So this is approachable. I mean, his talk is, I think, like 30, 40 minutes with questions. And that's it. I mean, it's short, right? If you think you've got an hour for a meetup, you're suddenly going, what do I do now? But at the same time, it's a good, it's nice and tight, which I think is pretty great. And one of the things I like about CSA stuff in general is and again, if folks are looking to contribute and help and get active in the security industry, this is one of those great places to go out to. We've talked about, the folks over at CNCF before, and CSA is another group if you're more interested on the white paper side. All these papers, they might have some industry people working on them, but they're also like completely open to the general public to come and become part of the working group and actually do the research if you don't know, or if you do know, just put your thoughts in. So the results of what you get are a little more real worldy, and I think that's what you're sort of picking up on there, Mike, as you look through what's in here.
Yeah, indeed. So it's always nice to see these types of documents that aren't just a crosswalk between this NIST standard to this ISO standard to this other standard. That's just an eye chart of acronyms and basically rows within a spreadsheet. So a great reference that looks consumable, usable. I think I'm going to use this to talk about one more report, and this report is talking about operational technology. And if there are, I'm going to add to the hackneyed, unfortunate phrases of InfoSec form. We take your security seriously. There's another one that's also goes like, insecurity by design remains very relevant, which, sort of guess the year that was written. So this is pointing out a decade of research of looking at basically operational technology, basically IoT within industry, not consumer-based IoT, the big stuff. And one of the things that really stood out to me that I think I just wanted to highlight from it was that, what was the number? 50% of devices they saw were not using. Sorry, I'm scrolling to get to my notes. There were vulns in firmware manipulation, or RCEs, were basically a third of all of the vulns they were finding. And for the firmware updates, only about half of the devices had some sort of authentication for the firmware, and of that, only about a fifth of them, or barely a quarter of them, had any signing of the cryptographic firmware, or cryptographic signing of the firmware. Sorry, and those are very basic approaches that we've talked about that do the basics of app inventory, for example. And we talked a little bit about SALSA in the past and the idea of just signed updates so that they can't be compromised. It can't be, intermediation attacks between them. So even with, and I guess the reason it stands out to me, sorry, trying to organize my thoughts here, is that signing firmware, I don't think falls into that difficult aspect of, a memory constrained environment or a CPU constrained environment, or something that's difficult to implement within C, C++ in dangerous ways. It's a pretty, it's a rare event. It only needs to happen when you install the firmware. And it's it's one of those things that's just, why not? This is my rhetorical question here, and I'm trying to pull out my William Shatner voice here. Just, why doesn't this happen? So I don't know who you want to impersonate now. That was pretty bad, by the way. But
well, you're safe. My impersonations are almost always going to be worse than yours, so there's no problem there at all.
Okay.
I'm just sort of scrolling through this thing, and it's it's. I don't want to just blow it off and go, yeah, they're right. There was I'll actually pivot to a quote I had from Hackaday. Had an article last week on their This Week in Security. It usually got some interesting stuff. So they had an article about IoT in the hot tub, and you can probably guess where that one's going. So I don't need to cover that. But what caught my eye, which I really like, is a sentence quoting, because as we all know, in IoT, the S stands for security. And it takes a second to sort of click in what's going on there, but there's no S in IoT to explain the joke in a minute. And that's sort of, we've seen this so many different ways. I think it's going to start to get better. I think that it's going to go slowly, just due to the nature of how these firmwares are designed and shipped. So as people who are probably working on brand new IoT things now, and working with preferably a new chip, because you want to use an old chip because it's cheaper. There's more experience around it. There's more software for it. The firmware's more, I can't say secure, more established. So there's reasons to use an older chip. But at the same time, for folks out there who are starting to use maybe a newer chip because it's lower energy or has Wi-Fi 6 or, I don't know, different, better BTLE or whatever the excuse is, as those chips start to come out, they're probably going to have better security on them, on both the chip and the firmware. So that's why I'm saying it's going to be slow to get this to where we want it to go. And it's easy in the meantime to talk about the existence and lack of security in what we have right now. So I think on this one, all I can do is hold my breath and wait for the future.
Oh dear. Hopefully you don't have to hold your breath for too long. This is going into dangerous territory. Well, while you're holding your breath, one of the things I will just a fun reference, NSA and CISA, I think, are listening to the show because we talked last week. And John, you mentioned that you even run PowerShell, and they're saying don't get rid of it. It's useful. And joking aside, I do think there's a good underlying theme here in the sense of, AppSec teams, incident response teams might like the idea of, we need to have the most bare bones system as possible, the trimmed down distro that we're going to run within our containerized environment with, or what have you. And we don't want attackers living off the land, so to speak, basically reusing system tools. So they have to bring their own systems tooling on there for setting up their C2, et cetera. Anyway, in this case, PowerShell is a pretty powerful tool, but it also has a lot of positive aspects for it for automated updates. A lot of Patch Tuesday updates, I think, rely on having PowerShell be present for it to be for those to be executed well. So there is this give and take of the idea, I think, of the broader aspect of how much should you trim down systems for small environments, and blocking that human access to prod. So we don't actually say humans shouldn't be SSHing in and using the command line, whether it's a PowerShell-based command line or just Bash or what have you. That's where also my mind went in this. In addition to knowing that NSA and CIS are looking out for you, John.
Yeah, they actually started a terminal chat session on my machine last week after I was talking to them. What's sort of fun about this one is to sort of take it in a different direction again. I sort of agree with, as much as I barely use PowerShell, I sort of come in waves of use of it, usually every, I think I said 3 to 5 years last time. I do like, for those who haven't used it or haven't played with it, it's pretty neat. They've sort of object orientalized the shell to a decent degree. And they've brought, at least I've used it more on Windows than on Mac, so you're able to access a lot of your Windows. I mean, most stuff on Windows nowadays is an object, right? Because of .NET, how they've done a lot of stuff there. So you're able to access a lot of those objects and manipulate them within PowerShell. But here's where I want to go, which is actually more interesting to me, is if you are in control, if you are in charge of maintaining Windows systems, or particularly Azure, there is a lot of security controls, which we've seen from the work I'm doing in my day job. There's a lot of security controls within the Azure world and within the M365 world that you cannot modify through a UI or from a CLI unless you're doing it from PowerShell. So, and someone's going to correct me, but that's what we found today. Not everything, but a decent number of them. So there's actually reasons to have this around. If you need to script and manage Windows systems, it's going to be easier to do it from PowerShell, right? Because you've got it's got a decent, I wouldn't quite call it an IDE, but sort of an IDE-like thing in there. It knows about the context it's in. You can run it as admin or without admin. So I think it definitely has some value to it. It'd be really interesting to see what type of adoption it's picked up outside of the Windows environment. But kudos to them for trying. But yeah, it's definitely not. What is it? Yeah, it's definitely not something I'd remove from a system as I'm hardening. So I'm with them on the overall statement.
Nice. Well, I think we're running out of time, and we do have a handful of articles to hit. So, John, which is the one that really speaks to you that you wanted to maybe take us out with?
Fuzzing. I almost lost a day on this one last week. I should be saying this out loud. My co-founder's going to kill me. But I think I found this, I don't know, Thursday or Friday last week. Wow, it's almost a year old. It hit my radar from Clint Gibner putting out on his TLDR sec on Twitter. But yeah, so on just on the way out, the headline isn't quite as exciting as I expected it to be. They went through what happened here is these guys at ADA Logics, when they're consulting on some other projects, they realized a lot of their customers need to know the security stance of some of these open source projects. So they started adding them into Google's OSS Fuzz project, doing setting it up and doing pull requests and getting them in so that then they were basically in a position where Google could then fuzz them. So it was interesting, to see how do you actually do that. You can go out and see the pull requests and see how you put those pieces together and build a Docker image and all those type of things. But what they found is after they did a few, they actually got a kick out of doing it, and they started doing more. They found it, dare say, fun. A lot of sort of common patterns they found out of it. They found a good number of vulnerabilities through the process. 2,100 bugs, 1,500 generic bugs, 559 security relevant bugs. If we say 3% of bugs are, leverageable, so that means they found about 20 bugs that could be attacked. 1,300 have been fixed as a result of this. But I think what caught my attention is you get about 60% down through this blog post. What is that OSS Fuzz process? Like I've already mentioned, the looking at the PR and actually seeing how they put together. But step one, find a relevant open source project. So, if you want to play with fuzzing, you don't want to deal with it on your own project. You don't have time to deal with the responses and actually patching things. but you want to try and help some open source guys out there, and there's a project you're using, you're not sure what it's like, and you think it might be a good target for this, hell, go. This is probably so horrible for me to say, but I think it's sort of interesting. Go add it to send a PR, like figure out how to do this and send a PR so Google starts fuzzing the thing. And you have to put in the contacts over at the project. It's probably a good thing if you tell the project, hey, I'm doing this, and get them to say that's cool. But you learn how a bit more about fuzzers work. You're helping the project out by getting them some fuzz time. And then also, hopefully, they'll have some bandwidth to go and fix these. Or maybe that's your next project after you do this, is you can go back and actually work on fixing some of those bugs that the fuzzer found from your efforts. So I thought that was sort of interesting about it, that like it's something that the overall community can help out with, and hopefully help sort of secure some of these projects.
Absolutely. And you hit on, to me, it's just, there was step 2 in this process. Understand if it has the potential for effective fuzzing, and then you actually have to put in some work to make the target, as they say, compilable with fuzzing included in it. And I think my last idea here is that, as a bit of a callback to our segment with Mike, he was mentioning about, doing security work or doing logging and adding visibility that is benefiting the SREs, benefiting the developers, and saying, look, we're looking at some, trying to do some security work here, and by the way, it's actually going to help you out. It's going to make your life better. Here with fuzzing, ideally, it's going to find bugs that just need to be fixed. So it's not even just the security relevant bugs. They found these, they call them generic bugs. I was a little bit surprised that only about 2/3 of the bugs overall had been verified and fixed, and about 1/3 of them were not fixed, which is okay. That gets into the prioritization aspect. But some of them, and I don't know a particular number of those, might have been false positives, because a little bit of my hope and desire of fuzzing that lends itself very much more to identifying bugs that cause crashes, and those crashes may have a security context, and so therefore they're a little bit more important, perhaps prioritization wise. But if it crashes, that's a fixable bug, and so that's just fuzzing in general can be helpful for a software quality aspect. So hopefully we'll have to revisit this maybe a year later and see what the false positive rate is within fuzzing, because hopefully it remains very low.
Definitely, after all our listeners go and help contribute some of those definitions into Google OSS Fuzzer, we'll be able to have more data to compare against.
That's right. You've got a week. Let us know, and we'll be able to talk about that and see how things are going. So there's the homework, perhaps. Well, thank you very much for that, John. I think that brings us to an end of yet another news segment. I want to thank everybody else for joining us. Remember, please subscribe, hit that like button, and check out some show notes. I think we have a week off next week for holidays in the US, but we will be back in 2 weeks to see you again on Application Security Weekly.